Modern streets often flood during a heavy storm, but 5,000 years ago, this civilization used sloped brick channels to move torrential monsoon rains away. They accomplished this without electricity. They had no heavy machinery to move earth, and they had no computers to model water flow. How did an ancient society build fully integrated urban systems under those severe constraints? To understand their success, we have to let go of the idea that early settlements grew organically over time. These cities were deliberate, calculated feats of engineering. The investigation starts with a basic logistical problem: designing a massive metropolis before a single foundation is poured. Excavations at cities like Mohenjo-daro provide physical proof of top-down planning. Notice the street grids cutting through the ruins. These roads were plotted to intersect at near right angles, dividing the space into organized, distinct neighborhoods. Builders laid down this entire grid, along with its extensive drainage system, long before any residential homes were constructed on top of it. Laying the infrastructure first is the same principle that guides modern urban planning today. The surface streets show a clear master plan, but the survival systems are buried right beneath the pavement. Moving past the street layout, the engineers faced a constant threat from the region's climate: seasonal monsoons followed by extended droughts. The city of Dholavira offers the clearest evidence of how they adapted to these extremes. Here, builders captured monsoon runoff and channeled it into giant excavated tanks with stone-lined walls, ensuring a steady water supply during dry periods. The builders of Dholavira turned the environment into an asset, transforming the settlement itself into a resource management machine built to guarantee long-term survival. Beyond these reservoirs, we have to look at how thousands of ordinary citizens actually accessed water in their daily lives. Throughout the ruins, archaeologists found a high density of private, cylindrical brick wells built directly into individual neighborhoods. This decentralized approach created a resilient urban structure. If one well collapsed or dried up, the rest of the neighborhood's water supply remained intact. Bringing fresh water in is only half the equation. The corresponding challenge is figuring out where the wastewater from thousands of households goes. Archaeological excavations reveal that ordinary, non-elite houses were built with dedicated interior bathrooms. Water from these washrooms drained directly into stone-covered trenches running beneath the public streets. Many of these drains featured removable stone covers. The engineers planned for maintenance, allowing workers to access the trenches and clear blockages. Public sanitation was a system-wide requirement engineered to protect the urban population from disease. Coordinating the construction of interconnected drains, wells, and streets across hundreds of miles requires strict mathematical discipline. The builders achieved this scale using early modular construction, driven by a single microcomponent, the fired brick. This diagram illustrates the mathematical ratio used to form the bricks. Archaeologists found these dimensions repeated identically across different settlements. Standardized proportions gave builders interchangeable units. They could assemble diverse structures, from protective walls to drainage channels, using the same basic material. While the physical ruins prove they successfully executed these projects, the methods they used to coordinate a society of this size remain an unsolved mystery. Their mastery of modular construction gave them the ability to produce complex urban infrastructure centuries before the Industrial Revolution. The grid plans, the covered drainage networks, the modular bricks, and the reservoirs all function together. The engineers of the Indus Valley turned the settlement itself into a single tool for survival: the integrated city. The underground channels mapped out by those ancient engineers operate on the same principles as the infrastructure buried beneath our sidewalks today, which leaves us with a lingering question: what other ancient knowledge have we forgotten over the last 5,000 years? True engineering mastery designs an environment that makes everyday life cleaner, safer, and sustainable. If you enjoyed this investigation, like the video, share it with a friend, and subscribe to Untold Indian Stories. Keep questioning the impossible.